Hello all, welcome to the Solocast of Firecode Tech. In these episodes, it's just going to be me, your host, Gus Gagliardi. There's going to be a range of topics, but I'm going to talk about specific technologies, installation standards, codes and how they work, as well as some other interesting topics that don't neatly fit inside of the context of a normal interview. Hello all, welcome to the Firecode Tech podcast. I'm your host, Gus Gagliardi. This is episode 39 of the Solocast series, and today we're talking about fireworks. I thought that it would be cool to take a look at the safety and the history and some terminology around explosives and fireworks in honor of the 4th of July. As always, thanks for listening, and don't forget to subscribe wherever you listen to your podcasts. Also, if you could give us a follow on social media and a 5-star review on Apple Podcasts, that would be a huge deal and a good way to support the podcast if you enjoy the content that comes out each week. So let's get into the show. I always like to start off with terminology and definitions around the fire and life safety subject I'm talking about. This gives you a solid base in the code requirements if you can understand the legal definition of the hazard that you are dealing with. In the U.S., for most of the jobs I've ever worked on, the IBC is the de facto code for commercial jobs. So let's start by taking a look at the definitions around fireworks and explosions in Chapter 2 of the International Building Code. Today I'm looking at the 2021 IBC. So there are many categories of explosives, and these categories all go back to how much the item or substance deflagrates or detonates. So let's take a look at a couple of these terms in Chapter 2 of the IBC. First of all, the term explosive is defined as in Chapter 2 of IBC with the following language: a chemical compound, mixture, or device, the primary or common purpose of which is to function by explosion. The term includes, but it is not limited to, dynamite, black powder, pellet powder, initiating explosives, detonators, safety fuses, squibs, detonating cord, igniter cords, igniters. The term explosive includes any material determined to be within the scope of USC Title 18, Chapter 40, and also includes any material classified as an explosive other than consumer fireworks. 1.4G by the Hazardous Materials Regulation DOTN 49 CFR Parts 100 through 185. So that's a lot to chew off, but basically they are trying to give a broad umbrella term for explosive. So the DOT has 6 classifications of explosives, and there are some subcategories within these classifications. These categories range from 1.1 to 1.6. And the most dangerous and fastest to explode are 1.1. Fireworks in specific are a subcategory of 1.3 and 1.4. So let's talk about what the definitions for fireworks are within the building code. Fireworks is defined as any composition or device for the purpose of producing a visual or audible effect for entertainment purposes by combustion, deflagration, or detonation that meets the definition of 1.4G fireworks or 1.3G fireworks. 1.3G fireworks is described as large firework devices which are explosive materials intended for use in fireworks displays and designed to produce audible or visible effects by combustion, deflagration, or detonation. Such 1.3G fireworks include, but are not limited to, fireworks containing more than 130 milligrams of explosive composition, aerial shells containing more than 40 grams of pyrotechnic composition, and other display pieces which exceed the limits for classification of 1.4G fireworks. Such 1.3G fireworks are also described as fireworks under UNO 335 by the DOTN. So as you can see, these fireworks are classified by the amount of explosive that is in the actual charge for the firework. If you've had much experience with hazardous materials, you'll quickly see the trend that in hazmat, usually hazard and severity are closely related to the amount of the hazardous item that is in storage. Moving on, 1.4G is small firework devices containing restricted amounts of pyrotechnic composition designed primarily to produce visual or audible effects by combustion or deflagration that complies with the construction, chemical composition, and labeling of the DOTN for fireworks, UNO 336, and U.S. Consumer Product Safety Commission, as set forth in CPSC 16 CFR Parts 1500 and 1507. So, in both of these fireworks definitions, there have been some federal regulation and also Department of Transportation regs that are tied to the transportation and protection for these products. So the first step in providing fire protection for fireworks would be to classify what type of hazardous material they are. You would need to look at a product safety data sheet or a STS for these products and make sure that they are classified as a 1.3G or a 1.4G firework. And then, after you've made the determination through your evaluation or through another expert that is suited to make the determination of the classification, the next step would be to define what form these explosives are in, and then quantify how much of the explosive you have when you are looking to store or use these items in a closed or open system. So, hazardous materials, if you exceed the maximum allowable quantity stated in Table 307.1.1 in the International Building Code 2021 edition, would require you to house these materials in an H occupancy. And depending on what you're storing, it will decide what sort of H occupancy that you are supposed to be housing these hazardous materials inside of. So we are looking at Chapter 3, more specifically Section 307. And in 307, there is a Table 307.1.1, which establishes the different types of hazardous materials, the maximum allowable quantities, and the applicable extra protections that can be provided in order to increase the amount of hazardous materials stored or implemented in open or closed systems. 1.4, 1.4G, and 1.3 are all listed in this table. Interesting to note that 1.3G is not listed in this table. So that's telling you that they don't care if it's a firework or not. Once you hit 1.3, you're either going to provide a H1 or a H2 occupancy at a very small amount of storage. At 5 gallons or 5 pounds of 1.3 division explosives, you are pushed into a H1 or H2 occupancy. H1 is the most protection that you can provide for an H occupancy, so you can tell that they are taking this very seriously when you are classifying something as a 1.3. 1.4 and 1.4G, however, are both listed in the table, and there is a greater amount of storage allowed for 1.4G. It goes from 50 gallons or 50 pounds to 125 pounds allowed stored without any of the modifiers to increase the amount for 1.4G. So buildings that are constructed as a H3 occupancy are built for a deflagration hazard. There are a variety of protection features that you can provide in order to safeguard a space from a deflagration explosion. H1, however, is a detonation hazard, and there are not so many protections that are available for detonation hazards. Generally, you have to separate these hazards from large buildings or structures or provide fire separation sufficient to treat the building as a standalone building. But there are setback distances and extreme fire protection requirements for H1 occupancies. NFPA 68 is the standard on explosion protection by deflagration venting. Deflagration venting is one of the strategies that can be used as one element to protect the spaces outside of where explosives are stored or processes that could trigger explosion are housed. If you want another good primer on hazardous materials, go check out Solocast number 7. I'll also drop a couple good links to some interviews that we've done that have great hazardous materials professionals. There's a whole NFPA standard for the manufacture, transportation, and storage of fireworks, and that's NFPA 1124. So go check that out if you want some more information on the protection and fire and life safety features around fireworks. NFPA 1124 categorizes facilities that manufacture fireworks as magazines. And I don't know why they call them that, but there are several different types of magazines and there are associated fire protection features for these magazines. Seems like this could be NFPA 1124 could be a whole Solocast episode in itself. So to end out this Solocast episode, I'm just going to go over some common building protection features that would be associated with protecting a building housing fireworks or 1.3 or 1.4 division explosives. Consideration needs to be given to the ventilation and heating of these structures and to make sure that heating in specific does not provide a source of ignition to the fireworks that are in storage in these facilities. Construction type and the fire-rated nature of the building construction also needs to be taken into consideration when designing a building for the housing of fireworks or explosives. Also, you want to consider the storage configuration and separation of groupings of explosives or fireworks that you are working with. Consider storage of other combustibles and separating them from any explosives or fire hazards. I would recommend housing your fireworks storage in a building equipped with a sprinkler system with a appropriately hydraulically designed system associated with it and perhaps some advanced detection for this kind of facility, even though in the U.S. it's common to see small transient facilities that house fireworks as stands for the sale of these products. I'll drop some links in the show notes to some resources I found from the Fire Protection Resource Foundation and NFPA 1124. And I think that's going to do it for this episode. Happy 4th of July and hope y'all were safe. And we'll see you next time. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.